Oh my goodness, guys, you're not gonna believe what just happened. I had to pull some strings, but I got my hands on some genuine computer parts from the Apollo 11 space launch. And some people always come up with the argument, hey, doesn't the Apollo 11 computer have less power than an average calculator today? I mean, they're right. That's why we're gonna compare it to the iPhone 6 and your modern computer. First off, let's start by unboxing this bad boy right here. I took the liberty of pre-cutting it for you guys, just, it wouldn't take too much time. But we just pull it down here. Get this bad boy out of the box. Right. Just throw that away. We don't want that box anymore. Alright, we got our computer right here. And up next, we'll start by unboxing our iPhone 6 right here. Just jimmy rig this out. Take out our bad boy. A little dirty, but that's okay. Throw that right over there. I don't want it anymore. And finally, before we get to these Apollo 11 computer parts, let's just open this bad boy real quick. Okay, now that this is open, we can finally get a look to see what we have inside this box of Apollo 11 computer parts. Now, I'm not gonna lie, I don't exactly know what's in here yet, so I'm kind of excited. Let's just take a peek real quick. Oh, cool! So first off, we have the AGS itself placed inside the lunar module, and in case people didn't know, there was actually 4 different computers for the Apollo mission. The first one was the Saturn Launch Vehicle Digital Computer, or the LVDC, which really focused on getting the rocket from the launch pad to Earth's orbit. Next, there were 2 AGCs, or Apollo Guidance Computers, like this one. One was placed in the command module to get from Earth's orbit to the moon and back, and the second, like this one, was placed in the lunar module, which really focused on landing and ascension back to the command module and the docking station. And finally, there was the 4th computer, which was luckily never used, the AGS, or the Abort Guidance System, which you can guess was a backup computer focused on aborting the mission in case there were any failures with the AGS. Alright, let's see what we have next. Okay, so this next part isn't exactly from the Apollo mission, but I guess it just shows how far we've come in technology since the Apollo mission. As you can see, this is a supercomputer from the early 1980s, a little bit after the Apollo mission. And it's the size of about 3 refrigerators, you can see. And you need about 300 to have the equal amount of power in just this iPhone 6 alone. So you can see how far we've come in technological advancement since the Apollo missions. Okay, so the next thing we have in the box here is the DSKY, or what they called it, the DISKY, the display keyboard. So basically, it's equivalent to today's monitor and keyboard, and what's so cool about this, no touchscreens, and the way they communicated with each other was they would put in 2-digit codes that they memorized, and it would come up to the next DISKY, and then they would have to use whatever codes they had to communicate to each other. Okay, up next, we have the core rote memory, or the ROM, which the DISKY didn't have any operating system or software, or iOS, the operating system like they have today. It didn't have any of that. Instead, they had to use this core rote memory, which not a lot. They had about 36,000 words total with this. And what's even cooler, as you can see in this next picture we have, they had to individually stitch every single 1 and 0 for every command inside this core rote memory. The cool thing about it is if anything happened to go wrong on the fly, they couldn't change it. They were stuck. But rarely with this ROM, it was pretty stable, so you wouldn't really get any bugs or issues like with today's technology. Alright, now let's get into the fun stuff. The numbers. So basically, the Apollo 11's guidance computer ran at a whopping 0.043 megahertz clock speed. When compared to the iPhone 6, which runs at a 1.4 gigahertz clock speed, but it has 2 cores. So basically, it runs 2 clock speeds at 1.4 gigahertz. And compare that to my computer, which runs 2 cores at 3.7 gigahertz. And don't even get me started on memory. So the AGC in the Apollo 11 really only had 1,028 words of RAM. Let me repeat that. Words. Compare that to the iPhone 6, which has a whole gigabyte of RAM. And compare that to my modern computer, which is still pretty low in standards for a modern computer. It only has 4 gigabytes of RAM. So let's talk about storage. So basically, before I get into this, you have to know storage is kept in a little thing called bytes. So the Apollo guidance computer had about 64 kilobytes, or 64,000 bytes. Compare that to the iPhone 6 on the low end, which contains 16 gigabytes. 1 gigabyte is 1 billion bytes. So 16 billion bytes in this little tiny iPhone compared to the 64,000 bytes in the entire AGC. Now let's compare that to my computer, which has 2 storage disks, one at 1 terabyte and another at 128 gigabytes. So 1 terabyte is 1,024 gigabytes. Compared to the AGC, this seems like an astronomical amount, and it is. But you have to remember, this is just a low-end computer from our time. The AGC was the highest end of supercomputers at the time of the Apollo mission. So let's recap. What have we learned today? So basically we learned that what started out in astronomy, a mission to bring a man to the moon, has grown into what computers are today, with an old iPhone 6, a low-end home computer, and even your average calculator today has so much more computing power than what the supercomputers of the time had for Apollo 11. It's exciting to think about 20 years from now, in which the ease they'll be able to send a man to the moon again, and maybe even Mars. We'll just have to see. Thanks to the guys who sent me all these parts from the Apollo 11 mission. Thanks again to Miss Cox for signing this project. Have a good day. Thank you.